So today we'll be doing the explaining to you how to perform normalization, how to normalize tables up to third normal form, free NF. A brief definition of normalization is a systematic approach used to minimize redundancy. It decomposes a table into several tables and are linked via relationship. So the idea behind normalization is that we have to remove duplicate rows or minimize duplication. Like here we have this table to normalize up to free NF. So when I have it empty here, this means we have 22 August 2011, 10 veg noodles, quantity 2, price 100. So this is repeating, this data on this line is repeating on all these lines. Same appears here. So first thing now, we have to see in such a table, why do we normalize? Because there are problems in the table. Because there are anomalies in the table. For example, for this table, we can find three types of anomalies: insertion anomaly, deletion anomaly, and update anomaly. So if I have to insert a new record in this table, if I have to insert a new record, let's say I have to insert a new menu. Okay, I want to put lamb noodles, for example. I will not be able to add it until I know what will be the price of that menu, what are the ingredients that are to be put in that menu, what type of ingredient, what beverage will be obtaining with that menu in that order, etc. So that becomes a problem. So insertion anomaly, if we were to insert a new menu, we will not be able to do so until an order has been made. Also, we will not be able to add ingredients until it has been ordered. So this is known as an insertion side effect anomaly. Because we can't just input data here and leave all these columns blank. It defeats the purpose of using a database. Deletion anomaly. If we were to delete a menu, we will lose valuable information about the order and beverage. If I go and delete this chicken noodles, I'm going to lose all the valuable information about that order. So this is a deletion side effect. Update. Since I have many rows having the same information, I might forget to update one of the record. So this becomes an update anomaly. Now, before we do normalization, we have to understand what is the concept of functional dependency. What is functional dependency? It is when one attribute determines another attribute. For example, I have my primary key. I should know which columns form a primary key that will identify all the records uniquely. So the primary key will become a determinant. So if we know A, it's going to determine the unique values of B. A table is in first normal form, 1NF, if and only if every non-key attribute is functionally dependent on the primary key. For first normal form, we need to have at least one table with compound key. So that's something important that you need to know. In my 1NF, one of my tables will have more than one column that will be formed a primary key. That is a composite key, a compound key. For example, now let's see this the table that we had. Put it here. We have this table. For example, if order ID, menu ID, and ingredient ID is put together, we can determine uniquely beverage quantity, menu name, ingredient name, quantity used, price, beverage ID, beverage name, and beverage price. If I know order ID, I can determine uniquely order date. So I've broken these in these two tables for my 1 and F. One with compound key is important. Now, second normal form. A table is in 2 and F. If and only if it is in 1 and F in first normal form, and that every non-key attribute is fully functionally dependent on the primary key. Now, the point important here, from 1 and F to 2 and F. In 1 and F, I know I need to have a table which has a compound key. To 1 and F to 2 and F, we need to remove partial dependencies. So second normal form applies to relations with composite keys, that is, relations with a primary key composed of 2 or more attributes. A relation with a single attribute primary key is automatically in at least 2 and F. A relation that is not in 2 and F may suffer from the update anomalies. The normalization of 1 and F relations to 2 and F involves the removal of partial dependencies. So if a partial dependency exists, we remove a partially dependent attribute. So what all this means, it means here, let's go back to our 1 and F. We have our compound key. So what does partial dependency mean? It means that if, for example, I know ingredient ID, I can determine ingredient name uniquely. So I don't need menu ID and order ID to determine the ingredient name. So we can remove this, that is another table. We can break another table, ingredient, where we are going to have ingredient ID and ingredient name. Because just all the 200, it's all chicken noodles. Or 201, I think there is a mistake. All chicken noodles are 200 and... Yeah, it's good. All chicken noodles, it's 11, the menu. All noodles is 200, 200. 202 cabbage. All 202 is cabbage. All 203 is chicken. So, knowing the ingredient ID, we can remove it. So, let's go in our 2NF. 2NF table here, we have removed ingredient ID and ingredient name. Ingredient ID here is the primary key. So uniquely we have 200 noodle, 201 carrot, all that. So the column of noodle, carrot, cabbage has been removed in the purchase details. Now let's go again in our 1NF. So this has been removed from this table. Now, if we know menu ID, we can determine menu name and its price uniquely. All veg noodles, their price is 100, or chicken noodles, their price is 150. And in our menu, if I know 10 is veg noodles, 11 chicken noodles. So we can remove, we don't need ingredient ID or order ID. To know that if it's menu ID 10, we would know it's veg noodles, and the price, we can determine it uniquely. So we have another table which doesn't depend on this and this. So we'll have menu ID as our primary key. Then menu name and price would be removed from here. So we have another table, menu. Here it is. So we have menu ID as primary key. So we have menu name and price. So partial dependency means that it doesn't depend on all the columns in the compound key to be determined uniquely. All right. So this is known as from 1NF to 2NF when we are moving to second normal form. So here now I have these 4 tables. Now, when we move from second normal form to third normal form, we have to check for transitive dependencies. A transitive dependency in a database is an indirect relationship between values in the same table that causes functional dependency. So to achieve a normalization standard of third normal form, 3NF, you must eliminate any transitive dependencies. All right, now let me explain to you what is a transitive dependency. Transitive dependency, we are going to refer to non-key attributes. Non-key attributes means not, but are not part of a primary key. So here we have non-key attributes. So we are going to compare column but are not part of the primary key, of a compound key or primary key. So here, if we know beverage ID, we can determine beverage name and beverage price. So this is why we're going to take this out and it becomes another table, beverage. They are non-key attribute. If I know beverage ID, I put it as primary key. I can determine beverage name and beverage price. So now in my 3NF, I have this table here, beverage. So this is, I keep a beverage ID here because we need it as a foreign key so that we can reference the details of the order. Same menu ID, we have it here. Ingredient ID, we have it here. So we can reference back to the table. So this is how we've normalized this table up to 3NF, third normal form. So now we have 5 tables. I'm going to do another example now. Another normalization question here. I have this table. This table, I have store code, store name, region code, region description, manager number, manager name, employee number, employee last name, employee first name, and employee date of birth. So this is in UNF, unnormalized normal form. So if we have to check the insertion anomaly, if we were to insert a new store, we won't be able to add a new store until we know who will be working there as manager, who are the employees who will be working in that store. It's a new store. We don't know yet. So we will not be able to add it unless we know all these details because we can't leave every column empty. That's why it is an anomaly. That's what the problem with a database. Now, to identify functional dependencies. So when we are doing normalization, first we have to identify functional dependencies. Store code. Now, check what I've seen here. If I have store code and employee number, I've put these two together as primary key. I can determine employee last name, first name, date of birth, manager number, manager name. This can be a table. My compound key is store code and employee number. Why I can't put store code and manager? Because if I put store code and manager number, it's going to repeat 111888. Then I will need another column to be able to determine uniquely. In my primary key, in my compound key, we can't have a value same. We can have it in one column. Second column, it has to differ. If I have 2 columns. If I have 3 columns in my compound key, I can have 2 columns same value, but the third column in my compound key cannot be same. So that's how I know I have selected my compound key correctly or not. When I've put store code, store name, region code, region description in another table. So I've broken this in 1NF into 2 tables. Now, region code if I know region code, all 2 in the region code is west, all 1 is east, all 2 is west. So region code can become a primary key, can determine region description uniquely. Just like manager number. All manager number 8 is Johnson, 12 is Washington, 7 is Ogallo. So if I know manager number, I can determine manager name. So that's why I decide on my functional dependency. For example, if I know employee number, I can determine uniquely employee last name, employee first name, employee date of birth. So 1NF, first normal form. A relation is in 1NF if and only if it is functionally dependent on the primary key. Now, store code employee number here is my primary key. So I've already identified in my functional dependency. If I know these two, I can determine employee L name, F name, employee date of birth, manager number, and manager name. Now check here, store code here, it repeats 111. We can't have the same value here. So we have 628. So it's okay. My composite key is okay. And it's determining unique values here. But what do you see? You see this repeating, you see this repeating, you see this repeating, you see this repeating. You see your store code repeating here, repeating. So this duplication has to be removed. That's why we are doing normalization. So my second table in 1NF, store code, define a store code, store name, region code, and region description. Now, 2NF, a relation is in 2NF if and only if it is in 1NF, and every non-key attribute is fully functionally dependent on the primary key. And as I told you before, from 1NF, to transform your table from 1NF to 2NF, we have to remove partial dependencies. So I had here in my 1NF, I had store code employee. So to transform from 1NF to 2NF, I have to examine the one that has the compound key, where it has more than one column as primary key. So in my case, store details has more than one column. So, and when I'm breaking the tables, I'm going to assign a name to each table, unique names. So now, if I know employee number, I can determine uniquely employee L name, employee F name, employee date of birth. For example, if I had put store code, a store name here, I don't need employee number, so store code would have determined store name uniquely if it was there. So now for my case, if I know employee number, I can determine employee L name, F name, employee date of birth. So when you're breaking your table in 1NF, you should already already know the rules of 1NF to 2NF, 2NF to 3NF. So I should already know what are the tables that will break to 2NF. So I should see the partial dependencies. I should be able to see how I'm going to remove the transitive dependencies. Then I know I'll be able to transform up to 3NF. So in my case, if I know employee number, I don't need to know store code to know employee name, first name, employee date of birth. So I'm going to break this into a table. So when I break this into a table, this will remain in the table. Manager number, manager name here. Here we don't have any compound key, so I don't have to examine it. So in my 2NF, store code, employee number, manager name. And now I have an employee table here, all the employee number as primary key, and these columns enter the employee table. Store code, store name, region code, it comes because it was not a compound key, it was a composite key. We don't have more than one column, so it stays, it transfers as it were in 1NF, from 1NF. Now, 2NF to 3NF, we have to check on the transitive relationship. So, transitive relationship is what? We have to check the non-key attribute. For example, if I know these are non-key attributes, they don't form part of the primary key. So, if I know manager number, I can determine manager name uniquely. So I'm going to have a table here in my free NF, a manager table, manager number, manager name. And here I'm going to keep only the manager number so that we can reference the table back later. Now for this table, let's examine the non-key attribute. If I know region code, I can determine region description uniquely. So since I can determine, so this is going to, they are transitive dependencies. So I'm going to put it in my FreeNF, a table region. I'm going to leave region code here and I'm going to put this in another table, a table region here. Region code, region description. So here I kept region code. So now I have five tables in my FreeNF for this question. Good. Hope you've understood and thank you very much for your attention.